Welcome to our module on front-end development, where we will explore building user interfaces using React.js. Our focus will be on creating interactive and scalable user interfaces, essential for modern web applications. Let us begin by understanding what React.js is and its key features for modern UI development. We will now delve into the core features that make React.js a popular choice for UI development. React.js is fundamentally a JavaScript library. This powerful JavaScript library is specifically designed for building dynamic and responsive user interfaces. It is actively developed and meticulously maintained by Facebook, now known as Meta. React.js significantly streamlines the entire front-end development process, making it more efficient. React utilizes a component-based architecture for structuring applications. This means the user interface is broken down into smaller, reusable, and manageable components. This modular approach greatly enhances an application's overall modularity and maintainability over time. A key feature is the virtual DOM, which optimizes UI updates. The virtual DOM allows for highly efficient UI updates, leading to faster application speeds. This efficient update mechanism directly translates into significantly faster rendering performance for your applications. React also follows a unidirectional data flow for managing data. This design principle ensures predictable state changes, making it easier to track and debug data. The unidirectional flow also simplifies data management, leading to more robust and less error-prone applications. In this section, we will explore JSX in React, a powerful syntax extension. We will learn how to write HTML-like syntax directly within your JavaScript code for components. Let us examine the basic syntax of JSX, which integrates HTML directly into JavaScript. JSX is a syntax extension that allows writing HTML directly within JavaScript code, improving readability. This code snippet demonstrates JSX, showing how HTML-like tags are directly embedded within JavaScript for components. Now, let us look at some essential rules for correctly using JSX in your React applications. Remember, all JSX elements must be wrapped in one parent. Use curly braces for JavaScript and class name for CSS. This example illustrates embedding a JavaScript expression within JSX using curly braces for dynamic content. We will now compare functional and class components, the fundamental building blocks of React applications. Understanding these two types is key to building effective and well-structured React applications. First, let us discuss functional components, a modern and often preferred approach in React. Functional components are simply plain JavaScript functions, making them concise and easy to understand. They directly return JSX, defining the user interface structure in a straightforward manner. This is the modern approach, largely preferred now with the introduction of React hooks. Next, we will cover class components, which represent an older but still relevant way of building components. Class components are based on ES6 classes, providing more features but also more verbosity. These components must extend React.component to inherit React's core functionalities and lifecycle methods. This represents an older approach primarily used for managing state and lifecycle events before hooks existed. In this section, we will learn about React props and how they make components dynamic. Props are essential for making your React components highly dynamic and reusable across your application. Let us begin by understanding how to pass props from a parent component to a child component. Props, short for properties, allow components to receive dynamic data from their parent, ensuring unidirectional flow. This code demonstrates passing a name prop from the app component to the welcome component, making it dynamic. Next, we will explore destructuring props, a cleaner way to access properties within your components. Destructuring props in the function signature makes your code cleaner and allows direct access to specific properties. This simplified syntax directly extracts the name property from the props object, making the code more concise. We will now explore React State Management, a fundamental concept for building dynamic and interactive user interfaces. Our focus will be on the useState hook, which helps manage internal data within functional components effectively. Let us begin by understanding the useState hook. a core feature for managing component-specific data. State stores dynamic data that can be modified directly within a component, unlike props. The useState hook is essential for this. This example demonstrates how to initialize state with useState at 0 and update it using a button click. Next, let us delve into how state updates work, which is crucial for dynamic user interface behavior. The setCount function updates the component's state and React automatically re-renders the component to reflect these changes. As you can see, the setCount function triggers an update, causing React to re-render the component. We will now explore the component lifecycle phases, which define a component's journey. Understanding a component's lifecycle is crucial for effectively managing its behavior throughout its existence. The mounting phase is the initial stage when a component is first brought into existence. During this phase, the component is created and then successfully inserted into the DOM. Next, we have the updating phase, which occurs when a component needs to refresh its display. This phase is triggered whenever the component is re-rendered due to changes in its state or props. Finally, there is the unmounting phase, when a component is removed from the application. In this final phase, the component is completely removed from the DOM, cleaning up its resources. Now, let us explore the useEffect hook, a powerful tool for managing side effects in React applications. This hook is specifically designed for efficiently managing side effects within your functional components. We will start with the basic usage of the useEffect hook to understand its fundamental operations. The useEffect hook is designed to handle side effects such as API calls or DOM manipulations running after each render. Here, useEffect sets up a timer, incrementing seconds, every 1000 milliseconds, and importantly, includes a cleanup function. Let us now examine the cleanup function, a vital part of the useEffect hook for resource management. The return function within useEffect serves as a cleanup mechanism, preventing memory leaks before the component unmounts. This line shows the cleanup function, which ensures the interval is cleared when the component is removed. We will explore client-side navigation with React Router, making your applications feel more responsive. React Router enables seamless page transitions in single-page applications, providing a smooth user experience. The first step is to install the necessary React Router library into your project. To install React Router, simply run the command npm install React Router DOM in your project directory. Next, we will set up the basic routes for our application within the app.js file. This code sets up the router and defines two basic routes, linking paths to their respective components. Now, let us see how to navigate between different views using the link component. The link component allows users to navigate between pages without triggering full page reloads, enhancing user experience. Finally, we will cover programmatic navigation using the useNavigate hook for more dynamic routing. This example shows how useNavigate can redirect a user to the home page after a successful login action. We will now discuss CSS frameworks for React, which help streamline design and styling. These frameworks are crucial for streamlining responsive design and ensuring consistent styling across your applications. First, let us consider Bootstrap, a widely popular CSS framework. Bootstrap offers pre-designed components and a flexible 12-column grid system for rapid development. Another excellent framework is Tailwind CSS, known for its utility-first approach. Tailwind CSS is a utility-first framework that provides highly customizable designs without writing custom CSS. Using CSS frameworks enables rapid development of user interfaces. They save significant time by providing ready-made styles and components, accelerating your development workflow. These frameworks also help maintain a consistent design throughout your application. This ensures visual uniformity, providing a cohesive and professional look and feel across all pages. Furthermore, CSS frameworks offer excellent support for responsive layouts. They come with built-in support for mobile-first design principles, adapting seamlessly to various screen sizes. Let us review the key takeaways from our discussion on React.js front-end development. These are the essential concepts you should grasp for effective React.js front-end development. JSX significantly improves code readability by enabling us to write HTML directly within our JavaScript files. Remember, React components are the fundamental, reusable building blocks for constructing any user interface. Props pass data from parent to child components, ensuring a predictable and unidirectional data flow. State, managed with the use state hook, handles dynamic data that changes within a component. The use effect hook is vital for handling side effects and managing component lifecycle events effectively. React Router is essential for enabling client-side navigation in single-page applications, providing smooth transitions. CSS frameworks like Bootstrap and Tailwind simplify responsive UI design, saving time and ensuring consistency.